friends will be presenting a project titled Electronic Voting Machine using ESP32. This project demonstrates how microcontroller based systems can be used to develop secure, efficient, and cost effective solutions for digital voting in controlled environments. The system is built using ESP32 microcontroller, an I2C LCD, and a self hosted secure Wi Fi network. And about our project, our core objective of this project is to design and implement a basic electronic voting machine capable of facilitating secure voting over a local wireless network. The ESP32 microcontroller serves multiple roles. It acts as the server, hosts a web interface for voting, and processes the incoming votes. An I2C LCD is used to provide visual feedback and display results in real time. And about the features, it is a ESP32 based server which manages a local Wi-Fi network, hosts the voting interface, and handles the backend logic. And it also has a said I2C LCD display, which is used to show voting options, voter confirmations, and final results clearly. And it also has secure local network. Since the system operates on a private Wi-Fi network hosted by ESP32, it is isolated from the internet, reducing vulnerability to external interfaces. And it is very scalable and economical.
So, hello, this is Mahanth. So, I'm going to be explaining you the design of the system as well as the connections. So, at the core of this project is the ESP32 microcontroller. It's ideal for this application because it offers built-in Wi-Fi and plenty of GPIO pins for input and output. For the display, we're using a 16 cross 2 character LCD connected through an I2C interfacing using the PCF8574T input-output expander. This expander is what makes this setup efficient. It converts the parallel interface of the LCD into a serial I2C connection. This drastically reduces the number of required data lines from 6 or more down to just 2. SDA is connected to GPIO 21, SCL is connected to GPIO 22, and power is connected to 5 volt and ground to ground. To communicate with the LCD, we use its I2C address, which is commonly 27 or 3F in hexadecimal. Depending on the module, if needed, we can run an I2C scanner sketch on the ESP32, confirm the address. For the input, we use 5 push buttons, 3 for voting, connected to GPIO 14, 27, 26, representing candidates A, B, and C, 1 to display the voting results, connected to GPIO 25, and 1 to reset all votes, connected to GPIO 33. Each button is connected between a GPIO pin and ground. We enable internal pull-up resistors on the ESP32, so we don't need any external resistors. This keeps the wiring clean and reduces component count. Okay. Finally, we added NFC-based access control using a smartphone. The smartphone writes an NFC tag containing a URL given in the slides. The ESP32 runs in access point mode, hosting a Wi Fi network called EVM ESP32. When the tag is scanned and the phone connects, the ESP32 temporarily enables voting for 10 seconds. This provides basic access control and prevents unauthorized voting. So, overall, the design is compact, low cost, and highly functional, combining clear visual feedback, simple input handling, and secure access, all centered around the ESP32. Thank you.
So hi all, I'm Nithin. I'm going to explain the software analysis and the coding part. So we have used the Arduino IDE to program the microcontroller. So basically there are some list of libraries which we have used for the functioning of the microcontroller, which will be explained in the coding part. Other than that, we have used C++ to program the microcontroller, and there is also the interfacing of LCD and NFC, which requires some libraries, which is clearly explained in the coding part. Now I'll be explaining the coding part. So basically, we can just split this code into 6 blocks. The first block, which is the library and the LCD setup, which is this one basically. This one is the libraries and the LCD setup. The next block is the web server and the web Wi-Fi AP block. So this is that block, and these two are the blocks which is important for the initialization of the LCD as well as making the Wi-Fi access point. The next block is the GPIO and the variable definition part, where we'll be defining the pins and the push buttons and the LCD. Likewise, the next block is the initialization block or the setup block, where the serial communication is started to the LCD display. It also activates the Wi-Fi access point and registers HTTP routes. Likewise, the next block is the outing logic. So basically, outing logic like is a basic if statement or the conditional statement, where when the NFC is read and the URL is accessed, there will be permission to vote. So there will be 10 seconds time to for a person to cast his vote. Likewise, the push button, pressing the push button will increment the vote count by one. So likewise, there are three push buttons A, B, C, which helps in the incrementation of the vote. Next block is the display block. The display block has two parts. One is the reset part, and the other one is the result part.
Hey guys, so I'm about to show you the working of our EVM, and here, so we have three pins here. This pin is for candidate A, and this pin is for candidate B, and this pin is for candidate C. This is our like to show all the results. This pin shows all the results, and this pin is for resetting the whole EVM. So now, my friend Nithin here will scan the NFC card through the phone to allow voting for 10 seconds. Yeah. So here access granted. So now for 10 seconds he can vote. So he has voted for candidate B. So now voting is closed, so we can't vote multiple times. So when I click results, you can see that there's a count of 1 for B. So this is the working of our EVM.
So, in conclusion, this project showcases the potential of embedded systems in creating accessible and secure electronic voting platforms. By using ESP32 and basic display modules, we have developed a prototype that is both functional and practical for small scale applications. So, thank you for taking time to review this project. Thank you.